Hi, in this video we'll continue to work on the production function FLK equal to max LK, and what we'll do is we'll find the shortened supply function. Okay, so recall that shortened supply function is something that you will obtain if you maximize the shortened profit, with respect to the output, that you should produce. Okay, so we are already given the shortened cost function. Okay, and we have this competitive firm, which is a price taker, and we would like to maximize its profit, with respect to output to get the shortened supply. Okay, so let me just write the objective here. So this is the objective of the firm. So firm wants to choose output so that it maximize PY minus CSWRKY. And recall that for this particular production function, this is the shortened cost function. Okay, so what we'll do is we'll figure out how the optimal choice of output varies with P, W, R, and Y. Okay, sorry, P, W, R, and K. How the optimal choice of output varies with price, W, wage rate, R, rental rate, and K capital. Okay, so we'll solve this problem. Okay. So one thing to note here is this, that RK is actually a sunk cost. So it's actually, so if you figure out what is CSWR K0, if you produce 0 units of output, how much will it cost you? So notice that it will cost you RK. So it's a sunk cost. So irrespective of how much output you produce, this is something that is gone. This is not only fixed, but it's also sunk cost. Okay, and it's non-avoidable. Okay, so what we can do is, we can just look at the variable cost. Because sunk cost, in this particular case, is subtracting a sunk cost or subtracting RK from the objective is not going to make any difference at all to the problem. So basically what we can do is we can write this profit maximization problem as follows: maximize PY minus variable cost in the short run okay. It may not depend on K and Y, so it doesn't really matter. We can just write the problem like this, and notice that this is just a fixed term. And what is this, this variable cost, in the short run is something that you can write it like this. Okay, so it may not depend on K or R. It's okay. We can, it's still okay to write it like this. It's completely fine. Okay, so notice that, it's WY if K is less than Y. Okay, so if you produce output more than capital, then the variable cost is WY, and if you produce output less than or equal to the capital fixed factor capital, then your variable cost is 0. So solving this problem is same as, solving this problem, which is just ignore the sunk cost, and please note that, if you really see, variable cost does depend on K and Y in this case. Um, it depends on Y, it depends on R. It doesn't depend on R, but it does depend on K. So it's okay. You just put these because your cost function depends on these, so you can always keep them, when you're writing your variable cost. I mean, it's completely okay. So maximize with respect to output py minus variable cost. Okay, so this is all that you need to solve. Okay, and if you just now this is actually a simple problem. So if you just plot the revenue and the cost, variable cost, you'll easily get the solution, because if you just see, there'll be cases. So output is something that you're choosing, so that's on the horizontal axis, and that's your revenue or cost. Okay, that's on the vertical axis. And now if you plot the variable cost, this is how it's going to look. So it's 0 till k. Okay, and beyond k it is wy. So if I have a line of slope w, if you have a line of slope w, this is how it's going to look. And we can remove this portion of the line, because that's where variable cost is 0. Okay, and at k there is a jump. Okay, and it's actually left continuous at k, because when y is equal to k it is 0. Okay, and it's not right continuous at k. Okay, and the slope of this line is w. Okay, that's basically the line wy. Okay, so this is how the cost function will look. Okay, and now if you plot the revenue, okay, so if p is greater than w, then the revenue function will look like this. In which case, notice that the difference between revenue and cost keep on growing as you keep increasing output. So when p is greater than w, in that case, there is no finite solution to the profit maximization problem. Okay, so why, so this is your supply function in the short run. Okay, so let me just write short run supply p w r k. Okay, and if p is greater than w, then there is no finite solution, so I'm just going to write an empty set. There's no finite solution if p is greater than w. If p is equal to w, in that case the supply function will look like this. In that case, your revenue will look like this. So it will coincide with this part of variable cost. Okay, and in that case, notice that at k, the difference between the revenue and the cost is maximum. And it turns out that that's the optimal choice. So it is going to be exactly k units of Okay, so it will be exactly k units of output that you would like to supply. And if p is less than w, and let's assume it's strictly positive, okay, p is strictly positive, in that case, okay, in that case, this is how the revenue function will look. Okay, and again, if you see over here, the profit keeps on growing till k, and after that, uh, you know the profit actually starts falling. Beyond this point, it's actually less than this, right? So it's this is negative actually. So even if you ignore the sunk cost, it's still negative. And here it's positive, and it is equal to whatever this difference is. Of course, we are ignoring the sunk cost. So if you ignore the sunk cost, then that profit, which is revenue minus the variable cost, that's positive over here, and that's maximum at k. So it is still k when p is less than w. Okay. Okay, and if p is equal to w, okay, in sorry, if p is equal to 0, okay, and it is less than w, okay, so this is basically when p is positive. Okay, so let me just rewrite this. Okay, so you can just write it like this, that w is greater than p is greater than 0. Okay, this is w is greater than p is equal to 0. Okay, in that case, you will find that there are multiple solutions, and you can actually produce anything from 0 to k, so because it's just going to coincide with this. Okay, and all these are profit maximizing. Okay, so basically it will be a interval. Okay, 0 to k. Okay, and that is how you can solve for the short-run supply function. Okay, and if you want to find the corresponding labor demand, okay, the labor demand in the short run, okay, then you just need to substitute this short run supply into the short run conditional labor demand function to get the short run labor demand function. Okay, so LSD, okay, short run labor demand, which is also going to depend on P, W, R, and K. Okay, and notice that if K is greater than or equal to Y, so it is going to be 0 always. So if k is greater than or equal to y, so then we know it's 0. Okay, and if k is less than y, then it is y. So let's just use this to just eliminate y here, right? I mean, we just need to write it as a function of p, w, r, and k. So let us see. So if p is greater than w, then of course there is no finite solution to the profit maximization problem. So the corresponding, so there is no finite solution to the, corresponding labor demand as well. Because if there is no finite output, that solves this problem, then correspondingly, there is no finite labor demand that solves this problem. Okay, so this is exactly again something that you can write it like this, that it is empty if p is greater than w. Okay, and if p is equal to w, okay, or if basically this is the case, if W is greater than or equal to P and P is positive, okay, then in that case the amount of output that you would like to supply is K. And since it is in this case, that your supply is K, so your corresponding labor demand will be 0, okay, because if W is greater than or equal to P, then in that case, we are in either this case or this case. In both these cases, your supply is K, and if your supply is K, that means this is K. So this case arise, right? Because Y is less than or equal to K, K is less than or equal to K, in which case your labor demand will be 0, okay? And if W is greater than P equal to 0, okay, in that case again, if you see, your supply of output will be from 0 to K, okay, which is again in this scenario, right? I mean, it's basically where L is 0, right? So it's either 0 or it does not exist, so the labor demand is either going to be 0 or it does not exist. So in all these cases where you are producing up to K units of output, your capital is sufficient, so labor is not really required. And if you're producing above K units, if you want to produce above K units of capital, that's a case that will happen only when P is greater than W. In that case, there is no finite solution to this problem, so therefore there is no finite labor choice, which solves the profit maximization problem. Okay, so this is your short-run labor demand function, and this is your short-run supply function. Thank you.